Different type of data.
All right, let's get some math done. Today's actually a pretty easy day. I claimed in my other class that it was the easiest day just to make sure they were paying attention. It's not the easiest day, but it's pretty darn close. Oh, you're using a word that I hesitated to talk about yesterday.
Uh-oh, that's
Do you know what parametric means?
No, I had to see the word.
Okay. It's basically, think about it, a box inside of a box. So let's just say that you have an equation that you just really don't know how to solve. Let's say it says a squared plus z squared plus 4 equals 9. I don't know how to solve that. What a parametric does is it takes this part right here and says, well, just call that d. So what they do is they say d is equal to z squared plus 4, and then you substitute that in, so you get a squared plus d equals 9, and then you solve that equation. And it turns out occasionally, sometimes it ends up being very easy to solve.
Is that why there's x1 and xt? And
Right. So each one of those represents a different thing that's being, it's kind of like a substitution within a substitution. And those are called parametric equations.
well, that's really easy. A equals
So then what is
a equals
sequential do?
2. And
What?
What is sequential do then?
Well, I don't know what I've seen that way. I got to figure out. I don't know what that is.
That equation isn't that hard. A equals 2.
I don't know if it's talking about literally a sequence or whatever. All right. Any questions on the homework?
It was homework.
When you will see your first parametric equation, usually if you take a class after calculus, and calculus comes in like 3 different flavors, so you would not see a parametric equation in pre-algebra or pre-calculus, but you might see one in college if you take higher level math. Triple nickel.
Why does it take that long to figure it out?
It's not, but it's what you do with parametric equations that's pretty nifty.
And you do with parametric equations while we're on the subject.
You know, off the top of my head, I never really did too much with parametric other than solve some. I was just simply exposed to the fact that it allows you to do a lot of high-level mathematics a whole lot easier because it's parametric, because you're not solving for some weird-looking cubic or quadratic. It ends up turning into a much easier equation. All right, any questions?
Oh my gosh, I just did this with trying to move the square. I'm literally looking at the homework, it's the same thing with the square. How you have to use the exact same variables to move something when you only have 4 variables.
There is some commonality.
Coding.
He's looking at tonight's homework, not last night, which is what we're on right now.
No cookies.
Last night's homework questions.
17 with a 5. No.
17?
No.
He's trying to make a joke. That he thinks he's-
That was 25.
Oh, we didn't have 25.
Yeah, so let's do that one.
All right, 25. A line through 5 7. Well, this is easy. A line through 5 7 parallel. You guys could do this in 5 seconds.
Oh wow.
A line through 5 7,
Parallel.
and it's parallel to y equals something. Is it 3x?
3x
Yeah.
minus 4.
Well, the rest doesn't matter. So what's the equation?
Y equals 3x.
No.
It would be
y
minus 7
Equals
3 parentheses x minus 5.
What did I tell you?
Okay.
He just burned.
Now, if you wanted, no,
You could
because
solve it in-
Jack was trying to put it into slope intercept form, but don't ever do that. Just leave it unless they tell you have to. Put point slope. It's ridiculously easy. All right, I'm gonna have to grade this because it literally gives me everything in point slope form. I mean, slope intercept form, not point slope. So for the ones that were in point slope, I have to grade that. All right,
You just want to pick it up?
I just want to pick it
All
up.
right.
I'm going back to chapter 1.
I have some people that are going back to chapter 1. People that are going to pass.
Yeah.
Very confusing class.
It looks confusing. on
If you had
chapter-
paid attention to the start, I said that I told my other geometry class that today was the easiest class of the year, but it really is. It's coming down.
Oh, it's coming down.
It's it really is. There's an easier class than this. I would argue that if we went back to the first lesson of the year, you'd find that would be the easiest class of the year, but that's because you already know how to do it. What we are doing is tomorrow's the hard class. And tomorrow's nothing but proofs. Field day, we got this. Field day is going to separate the chapter test. So we're going to do a chapter review on Thursday. And then a weekend and a field day, we better do it a second chapter review just to make sure we don't screw this up. So we better not have a snow day, otherwise we're not a chapter 13 test. Because we're out of days, right?
What if, okay.
There's not going to be a snow day. But
What if everything feels constricted?
although we were kind of thinking maybe possibility there would have been one today,
Yeah, we would have got rid of one of the chapter 13
which
reviews.
would have gotten rid of the chapter. I would not have given you the test.
Wait, what do you mean?
Really?
Would you have actually taken, wouldn't you have removed one of the review days and left one, you have 2 review days in the test?
I'm worried about 3 days off from math, and some of you wouldn't even crack a book.
That's why we don't do Thursday review day if we have this one.
That's
Then we
why,
just have Monday and-
if today was a snow day, that'd make 13.8 on Wednesday, 13.9 on Thursday, Friday's snow day. On one day, we have to review within the test.
Could have done that.
That
Like
would've
not
been-
teach 13.9. I probably would have been a
Wait,
better
why
choice.
Why would you do 2 chapter reviews?
Because I'm worried that Friday, Saturday, Sunday, nobody would look at anything.
That's
Well,
why I
that's-
have a review on
That's why
Monday.
you remove the review. That's why you remove the review, and now you have the review is still right before the test. You just have
Yeah,
one.
but there'd be
review.
one day. Right?
Yeah,
Okay,
which makes a
well,
lot more
that's
sense.
But then you would have
If you're
forgotten everything because we would have taken 1, 2, 3, 4 days off.
No, because we would have done it on 13.9. We would have to think about our previous chapter to be able to do that one.
Luckily, none of that's going to have to worry about. Okay. Homework.
Yeah, it's gonna be
These
so hard.
are very quickly done. I mean, this is maybe 10 minutes worth of homework.
Does that mean I get to work on history all night? Yes.
Some of you will be able to do this in 5 minutes. It's that easy.
Can I do it in 2?
Not 2. There's too much stuff to go. Now, I'm going to warn you. You got to put some thought to it. I'm going to show you the most efficient way of doing it, and the most efficient way is the answer. I'm just going to warn you. Some of you are going to think that you know the answer, and it's not the most efficient way. And it'll make more sense once I give the class.
Whoa,
Yeah,
man,
that's
that's
it.
really, really offensive to me.
And 1, 2, 3. There is no. Oh, that's not true. Only one of the. No, it is true. There is not a single. There's not a single one for homework tonight that uses more than 2 variables. If you use more than 2 variables, you've done something wrong. It'll make more sense once we do a couple ones. Okay, so tomorrow's the class on proofs. Today is get ready for the proof day. So I'm gonna do a proof just to show you what it looks like, but we're not gonna actually do a single proof for homework tonight. It's the setup for the proof. All right, so it is an easy day. It says new kind of proof. I've shown you one of these before, but I never really named it, but I'll name it today. So these are called coordinates proof. Some people call them visual proof. Visual proofs mean I draw a picture, right? And I prove it from the picture. And visual proofs can be done without a coordinate plane, but we are going to do our proofs on a coordinate plane. And the reason why we put it on a coordinate plane is because we can use the numbers on the coordinate plane to help us in the proof. You'll see why here in a second. Okay. The challenging part of a visual or coordinate proof is the setup, which is what the entire day is about today. All right. So I take a coordinate plane, I take a shape, and I put the shape on the coordinate plane. Doesn't sound very challenging, right? The challenging part is that you're going to have to come up with the vertices of the shape. If it's a circle, well, then you got to come up with the center and the radius. But if it's a polygon, you got to come up with the coordinates of the vertices of the shape. And the issue is you're not going to have any dimensions. You're going to be given a shape without any dimensions. It's not going to say like a triangle that has a side length of 3. You're not going to be given that. You're just going to be given a triangle. And you got to put it on this. Well, how do I do that? That's what today's class is on. So it sounds like it's not going to be easy, and it ends up being pretty easy. All right. So watch me do this proof, right? I'm going to do this proof. I'll hand this out in a second. All right. I don't know if you remember this. This is a long time ago. Chapter 5, by the way.
Whoa.
We never did 515. In fact, 515 it says the proof will be done in chapter 12 or 13. What are we on? 13?
No, we're
13.
on 14.
Well, it took a long time to prove this thing. You probably don't even. We used this, by the way, last chapter or a couple classes ago. We used 515. 515 is the one that says that if you have a right triangle and you connect the right angle to the median or the midpoint, that what? Remember?
That all three of those are equidistant from M.
They're all congruent. Those three parts are congruent. Okay. We never proved that. We just said, okay, let's do this. I'm going to prove that, and I'm going to prove it. You know, a typical way of proving it would be, I don't know, you come up with, you know, congruent triangles or something like that, and well, what?
Why didn't we just make a square and then say that since the diagonals are equal?
We could have done that, right? But I believe that would have been, I don't know, yeah, we could have done that. Yeah. All right. I'm going to prove it using what we learned this chapter, and we're going to put it on a coordinate plane. So I'm going to take that shape right there, put it on the coordinate plane. Well, the issue is there's only one number on that triangle. What's the one number that we get?
90.
We got a 90-degree angle. We know nothing about it. We don't even know if it's isosceles. Could be. Right? Looks isosceles. We don't know for sure, though. So the only thing we know for sure is that angle is 90 degrees. So suspiciously, I'm going to put the 90 degrees at the origin. In other words, I'm going to put point O at the origin. See what it did? Now, big picture here, I put it at the origin because I now know the coordinates of point O. What are the coordinates?
0, 0.
Okay, well, that was easy.
If you did us on a graph paper, we could find all the coordinates.
Yeah, but here's the issue. I don't know. I literally don't know how long that is. If I put it on there, then I'm assuming that it's a certain distance. So notice I don't have any tick marks here. I'm not making any assumptions that it's 3 units long. Okay. Well, point O is really easy. It's 0, 0. Why is this not clicking? All right. Point P is the one, and you kind of just saw the answer there. If you think about M is the midpoint of the hypotenuse. You see that? And I'm going to claim that its coordinates are 8. I just chose A, B at random. I could chose any variables,
Oh,
right?
you could do A dash 0,
How do you get to point M if you start at the origin?
0 dash P.
Yeah, but how do you get to M if you start at the origin?
Find the middle of R and P.
You find the middle of RP, yeah. And then you
Like literally, if I were to plot point M on the graph, how would you plot it?
find the middle.
Find the coordinates.
Half the minus.
If I said it was at 3, 2, what would you do?
Put it at
Put it at 3, 2.
So how do we go from the origin to point M?
over A.
Ah. So we go over to A. So this point right here is A. And then we go up to B. So that means that this point right there,
Oh, I know.
B.
Right here in your triangle. That's how
Okay.
it's square.
But M is the midpoint. So therefore, if this is A over, how far over is P? It's 2A. And since P is on the origin, then its coordinate is 2A comma 0.
Okay.
So where's R?
2A, 2B. It's 0, 2B.
0 comma 2B. So that point right there would be 0 comma 2B. Notice we went from having, with exception of the angle, having no coordinates that we now have coordinates, except the coordinates are all variables. I'm trying to prove that this OM, by the way, this is the midpoint, so we are given, because we know it's the midpoint, that RM is congruent to PM by definition of midpoint, right? So to prove that the OM is congruent to the other pieces, choose either piece, they're both the same, pick one. Okay, so let's show that OM is equal to RM. How would we do that? Using the stuff that you learned in this chapter. Distance formula would prove that the distances were equal, right? Before we would have said that, hey, I need to show that this triangle is congruent to this one, CP, CTC. Because we don't know what kind of triangle it is, we can't. We can certainly show that this piece, and this piece are congruent, right? But I don't know how. I mean, 2B and 2A. I don't know if those are the same or not. It could be. By the way, they would if it's an isosceles triangle. Okay, so distance formula. Let's calculate OM first. All right, McKinley, you remember the distance formula?
Give me a second.
Square root of x2 minus x1 squared.
Oh, quantity, yeah.
So what do you want me to do?
Distance equals square root.
Big long square root symbol.
Yeah, big square root.
Yeah.
symbol, and then x squared minus x1.
X2 minus x1.
Yeah, then.
So where are my x's? Well, there's your first x. Well, that's pretty convenient, right? Zeros, we like that. So that would be a minus 0 squared. Keep talking.
Plus y squared minus y1.
y2.
y2.
And that's b minus 0. So that's pretty convenient. Therefore, what do we get?
The Pythagorean Theorem.
Yeah,
We'll certainly look. Well, the thing was, distance is the Pythagorean theorem.
a squared plus b squared square root.
Okay.
You get a squared plus b squared equals OM squared.
No.
Yes.
If we wanted to square both sides, let's not. We could. I mean, this literally says OM is equal to this. Now, this isn't a very satisfying answer, right? Because it doesn't say literally how long it is.
So it's a plus. No, it's not.
It's not. That would be freshman dream, right?
A correction.
You remember the freshman dream?
Yeah, a.
You think that if you do a plus b squared, that it turns into that. That's not true. That turns into a squared plus 2ab plus b squared. All right. But here's the kicker. We don't need to do it. That's fine. That's a perfectly fine answer. That's how long it is. Don't know literally how long it is, but it's equal to that value. If I can show that RM is the same thing, even though it's variables, we're good to go. So let's see what RM is. So here's RM. Here are the coordinates. Tell me what to do.
So a minus 0.
That's a squared.
So a squared.
And then b minus 2b squared
What's b minus 2b?
is negative b.
Negative.
And what's negative b squared?
B squared.
It's the same thing, right? B minus 2b is negative b, but when we square it, we still get, hey, look, they're exactly the same. That's supposed to be in blue, but I guess it is. It's literally the same thing. We're done. That's the whole proof right there. Now, I still have to claim that RM is equal to OMY because of midpoint. And we're done. I've showed it all three are congruent. So there we go. This is the power of a coordinate proof. The power is you take a shape, you put it on the coordinate plane, you figure out what the vertices are, and somehow that leads you to be able to prove something. Now, this doesn't work with every shape, but certainly worked for this particular proof. And it worked very easily, too. This is also why we had to wait to chapter 12 to prove this, because we didn't have the distance formula back in chapter 5. Okay, cool. That's what we're going to do tomorrow. Tomorrow's homework is nothing but proofs.
Oh, okay.
Today is we take the shape, we put it on the coordinate plane, and we come up with, because we got to practice this, we got to come up with the vertices, or the coordinates to the vertices. Tonight for homework, be careful. I know you guys, even though I told you not to try this until we got started, because there is a specific way we need to do it. And the specific way is we want to write it with the fewest variables possible. There is no answer tonight that uses more than 2 variables. If you're using more than 2 variables, you're doing it wrong. Well, you're not doing it wrong, you're doing it not efficiently.
I'm still doing it.
Okay. So the basic idea for suggestions for coordinate proofs are this. Use the origin whenever possible. Put the shape somewhere on the origin. Put one of the vertices on the origin. You immediately get 0, 0. We like 0, 0 for calculations. These are suggestions, by the way. The second thing is use the x and the y axis. Remember, on the x-axis, any y value is 0, and on the y-axis, any x value is 0. So we get more zeros. We like that. If the figure is symmetric, like an isosceles triangle, or a right triangle, or an isosceles triangle, or an isosceles trapezoid, put it so that the axes, either the x or the y, cuts it in half at the line of symmetry. And that way you can do some, I'll do a couple examples. It just makes you'll see why it makes your life a whole lot easier. All right, your goal is you need to be able to identify all your that's what tonight's homework is on. Literally, they name, what, Jack, 2 of them or something, they leave you with question marks? Something like that.
Some of them, yeah. Some of them they gave you 2, some of them they gave you 1.
Right, sometimes they don't give you any, right? Our goal is to be able to name the vertices, their coordinates. So I usually lose a couple people just on that basic concept, so we have to do a bunch of them. I have 9 examples. We may or may not do all 9, but I got 9 of them ready for you. Okay, so the concept itself is a little bit hard to grasp without actually doing some. So we're going to take a shape. I'm going to give you a shape. This is tomorrow. You're going to put it on the coordinate plane. You're going to name the coordinates of the vertices. Tonight for homework, I believe every single one has already been put on the coordinate plane. Yes, every one has already been put on the coordinate plane for you. Tomorrow, that won't be the case. So that's why I made this class where I'm forcing you to do this. You're going to determine the coordinates of all the vertices, and the fewest variables is the best answer. Fewer the variables, the more likelihood you will be able to do the proof. You can write anything with an unlimited amount of variables unless you have a TI-84, right, Ben? You didn't get the joke? You just literally said the prob was, I only have 26 variables. So when you have an unlimited amount of variables, seems like a simple thing. I just label everything A, B, C, D, E, F, G, H, I, J, K, L, whatever. No, we want to use the fewest number of variables. And you saw why, because when we actually do the proof, things cancel, things subtract from each other, we get zeros. It's what we want to do.
It looks clean.
Okay, so McKinley, you're up first. What's the shape? This is box 2.
C-line triangle.
Who?
C-line.
It's a sea lion trophy?
Yeah, no, it's a C-line triangle.
Okay, a sea lion triangle. Do you know what Operation Sea Lion was? You know the Battle of Britain?
No.
What was the Battle of Britain?
It was a battle over Britain.
During World War II, the Battle of Britain was when
Oh, the Germans were bombing?
they were ready to invade.
Oh.
England was the last country left, literally, with exception of Switzerland and Spain and Portugal.
Switzerland didn't get it on.
Germany had invaded every single country in Europe. Every single country in Europe, right? Finland? No, Finland too. But Germany had taken over everything with the countries, with the exception of England. Spain was kind of neutral, so was Switzerland. So Battle of Britain is when he launched, thousands and thousands and thousands of fighters and bombers to go attack England, and they just rained bombs upon the civilians. It's called the Battle of Britain. Well, what was supposed to happen right after the Battle of Britain was Operation Sea Lion, which was the actual invasion of England. All right, there's your trivia for the day. Operation Sea Lion never happened because England won the Battle of Britain, which allowed us to send all our troops and planes to England to use as staging bases to invade Europe. Okay, you get to place a sea lion trophy, a scalene triangle on this. What is the most likely way of placing that onto there?
0. Place it where one of the points
It's him talking.
Okay, where 0, 0 is.
Okay, and how about where are you going to put AC?
On the x-axis.
That would be the most common, right? So that's what we're going to do. So you're going to place the shape on the coordinate plane. You're going to determine the vertices, the ones with the fewest variables, the answer. So I'm doing McKinley's choice. Well, clearly A is at
0, 0.
Well, where's B?
2.
It's on the x-axis.
B is not on the x-axis.
My bad. I thought you said C. Well, B is just there.
Where is it?
Well, it's
A J, comma K.
Now it is a scalene triangle.
C-line.
Well,
If it were equilateral or if it was isosceles, maybe we could say something more about it. But it's scalene. I don't know how tall it is. I don't know how far off to the right it goes. I just know that it's not on the y-axis.
well.
Therefore, what do you have to do?
You have to
Make up 2 variables.
Got to use 2 variables. Okay, so I'm just going to go in alphabetical order. The book chooses some weird letters, right? There's no rhyme or reason for their choices. I'm going to choose, I got to use 2 variables. So I'm going to use the first 2, A and B. So, I lied, B and C.
I wonder why.
I thought I chose A and B, but apparently I chose B and
No,
C.
I think it's because of the
C is A, comma 0.
Yeah.
Or 0, comma A. Wait.
A
Okay.
comma 0.
Where's this?
A comma 0. Because you have A distance away, comma 0 still on the x-axis.
I chose D. A would have been fine.
Probably because you have an A there.
How many variables did I use?
3.
The 3. And
It's
you said
3.
we need to use 2. Well,
I used, well, this is classwork.
you can actually replace that B with a different variable. Not
Yeah,
different
but it
variable,
would
you can
still
replace-
be 3 unique variables.
You can replace that b with an actual thing.
What do you mean?
Never mind. Listen to me.
Okay.
Anyway.
And the reason that I can't replace, I can't like by let's just assume that it's equal to 10, right? It goes up 10 or it goes right 10 or something like that. Well, you can't claim that because all we're told is scaling. We're not told any information. All right, so we use 3 variables. Is there another way of doing this? Like placing that on that? What do you think, Anna?
Could make A, B on the y-axis.
We could turn it and twist it. Let's see what would happen. So if we turn it and twist it, we got it in 3. If we can get it in 2, it's a better thing. If we can't get it, then it's not a better thing. She's saying take A and B and stick them right here. So here's A, here's B, and that would mean that there's C. Okay, where's A?
0, 0.
Okay, where's B?
0D,
0D, all right.
and then you got BC.
And then, okay, so how many variables did I use?
3.
So I didn't make any progress.
Just flipping 0 and D.
Okay. Now maybe you wanted to do that for some other reason. I don't know. Maybe if you were told C was, I don't know, but it didn't get us any better than the original one. Any other way of doing it? I didn't pick that one, but that can be done that way. By the way, that'd been perfectly fine. Any other way?
You could put AB on the x-axis, or you could put AC on the y-axis, or you could put BC on the y-axis, or you could put AC on the.
How about if we put B on the y-axis?
That's what.
You were saying sides. I'm just saying just point B. Okay. Leave AC on the x-axis and put B on the y-axis. Let's see what happens for that. Oh, anybody want to take a guess whether this is worth thinking about?
Yeah.
It's a scalene triangle. So where's A?
AB.
Negative, negative.
Okay.
Negative.
Now where am I getting the negative from?
Because it's in the
Fourth,
Because you'd have to go over, that would be negative, and then down. Where's B?
Negative, positive.
Negative C, D, right? Where's C?
Is positive, negative.
E.
E, negative F, right? So 6, yeah, that didn't get us anywhere. The other way would be to put B, right? Well, we don't get a 0, 0. This would be
0. You still get 2
0,
variables.
comma A.
not 0,
Or
negative A,
negative
comma
A,
0.
comma
So negative A, comma 0, where's B?
Is 0, comma
0,
B.
comma.
0, comma B, where's C?
Is a 0, comma
No,
negative.
it's C, comma
C, comma 0. So how many variables?
3.
Did we ever figure out one to get to 2 variables?
No.
No. Now, the problem with this whole process is this isn't even the proof. This is just the start of the proof, right? Tomorrow, when you're struggling with these proofs, your goal is simply to write the fewest number of variable possibles and then go with it, okay? These were the 2 that we came up with that gave us the fewest possible. They both had 3 variables. I don't know. Me personally, this one requires the least amount of thinking, right? I probably wouldn't even have tried that one because notice it has a negative now. I don't know. I'm not saying this is any better. It's not mathematically any different. They both have 3 variables. Tomorrow you're going to have to do some picking and choosing. All right, you're doing this because tomorrow we're going to write a proof. And as soon as we do that, then we can do some calculations for distance formula, midpoint formula, the slope. We can determine some things as soon as we throw in the coordinate plane. All right, Ben, this one's yours. Right triangle, where you want to put it?
I want to put on the origin.
What on the origin?
I want to put A on the origin.
Okay, since it's a right triangle, therefore B would be,
On the y-axis.
and then C would be on
The
the,
x-axis.
all right, that, I don't think of anyone that wouldn't do that. Okay, where's A?
Well, A is at 0, 0.
Where's B?
B is at 0, A. Or A,
You had it right.
yeah, 0, A.
And C is at,
B, 0.
okay, I don't think there's
2 variables.
I don't think there's any way of getting 1 variable, right? But an equilateral triangle, there is a way, right? But not with a right triangle or scale. I'm not sure why I put that. I noticed that last time. I thought it was a mark on the thing. It's not. Just a mistake. Okay, cool. I mean, there's other ways of placing that triangle there, but that's probably the best one. All right, another way would be,
In the middle. Yeah, look really
How about that?
bad. Oh, okay.
So McKinley, where's A?
Oh, A is in the negative.
Negative.
Negative 0. No, yeah, 0 comma. No, wait, a negative A comma 0.
Perfect. Where's B?
Negative B comma.
Oh, no.
C.
To get to B, you go here first and then up.
Oh, okay. So just negative B comma.
How far did you go across?
I don't
With
know.
the same cross as you did to A.
Negative A comma B. Yeah,
So negative A,
comma B.
and where's C?
0, 0.
All right, two as well. Would most people choose this? Probably not, but you'll notice it does have the same amount, still two variables. Okay, that's kind of
But
interesting.
it seems more complicated.
It is, and this is what most people would choose. Okay, cool. Some other shapes. We got an isosceles triangle.
That's not too hard. You just have to.
Where do you want to put it?
Well, I would put A.
Let's put it in the center.
What do you mean on the center?
In the origin. I put
What's
A-
on the origin?
A on the origin.
A on the origin?
Yeah.
All right.
Then you just do.
It's
Actually-
isosceles.
Let's not do that.
Okay.
That's gonna be a bit harder.
And we're
There's a
told
way
that
we can get
This
one.
is congruent to that. Okay. So we got 0, 0. What else?
Well, let's say that point C, aka the other point on the x-axis, right there. Let's call that A comma 0.
Where's there?
Well, that's half of A. Because it's isosceles, we know that.
Isosceles, so it's halfway here is there.
Yeah, so that's
So
A
So
over
that's-
2 comma B.
A over 2 comma B. So how many variables we use?
2.
Okay, that'll work.
Another way we could do this is if we put the B on the y-axis.
That's kind of what I was thinking.
Yeah, I realize that.
But by the way, that was perfectly fine. Right? In fact, that's what I did, except I chose,
You choose the
I
other
just don't
way.
like fractions, right?
Now just A times 2.
So instead of it being,
2A and then 2A
Right.
comma 0.
I mean, that's literally the same thing, okay? The other way would be what you said, B there. So therefore, A is at,
A is at negative A comma
Okay.
0.
B is at,
A comma 0. Oh, B, my bad. C is at A comma 0.
B comma 0, or 0 comma B, I
And
just screwed
then
that up.
A comma 0.
Okay, cool. Still two variables. Okay. All right, that wasn't bad. Anybody lost? The nice thing, that's not for this class. The nice thing about this is for tonight's homework, they're already going to have it placed there. The issue is tomorrow is they're not going to tell you where to place it, and you're going to be wondering if you've got the right configuration. All right, you do have lots of options, right? Which one is correct? Well, definitely the one with the fewest variables, but when you have one where I had two variables, which one do you choose? Choose the one that doesn't have fractions, choose the one that has a 0, 0. I mean, make your life easy, right? That's how you choose. All right,
This is gonna happen.
Anna, where are we gonna put the rectangle? An A, what on the Y? Okay, that's what I would do too. So therefore, A is at, B is at, C is at,
B comma A.
sometimes when you have these quadrilaterals, it's easier to do this point next than to do that point.
Yeah, it definitely is. That's 0 comma B. D is 0 comma B.
Okay.
And then using that, we get B comma A.
Okay.
2 for that.
If you had done this one first, you might have used different letters, but. All right, that one isn't too bad, and that's where most people would place. Could you, oh, by the way, how many variables again? 2. That's crazy. You just had 2 variables. Is there any other way of doing it? We get 2 variables? Which way?
Well, let's put C and D on the y-axis.
Okay, that's the same thing, just reflected.
Oh, reflected on the x-axis.
But a different, same thing, just reflected over the x-axis. Is there a different way of, you're not just doing a reflection, you're doing something really different.
How about we do a diagonal reflection?
That would be very different, but then you would wind up with that, and well, it's the same basic thing. You did a diagonal reflection. How about if we don't put anything on the y-axis, and we split it straight down the middle where the line of reflection is?
Oh, then it's just,
Right,
yeah.
here's the line of reflection, so let's put that on the y-axis. So where's A?
Well, A is a negative A comma 0.
B?
Negative A comma neg B.
Okay. D.
A comma 0, and then just
A comma B. That'll
two
work.
variables still.
Still two variables. Now, you might say, well, yeah, but there's less zeros now, and there's more letters, number of letters. So not like type unique letters, but there's way more A's. There's 1, 2, 3, 4 A's and 2 B's. And the previous time we had more zeros. We only had 2 A's and 2 B's. So this would be more efficient for the math that you might have to do for calculations, but it's still the same number of variables either way. Okay. All right, so here comes the first challenging one, and it is the, take a guess.
Trapezoid.
All right. Parallelogram. All right, you basically just have to see this trick one time for you to understand what's going on. All right, where do we want to put it? A on the origin, that's where most people would choose. Okay, cool. Where's A?
A 0 0.
Where's B?
A B, yeah.
We don't even really know, right? So
That's the A
A,
B.
B. Okay.
Then
Now think of this.
we should do D next.
Let's do D next. So where's D?
0 comma C.
C comma 0.
C comma 0, thank you.
Where's C?
We can figure it.
So it
Well,
would be
well, for angle
something
C,
comma B.
The easy one is the Y.
Y is,
The easy one is the Y. How tall is it?
that is incorrect. It's the
B
It's
tall.
the
B
X.
tall.
No,
B
it's
tall.
not.
No,
It's
It's-
C.
it's
It's C
B.
plus.
it's B tall.
B tall.
Yeah.
Okay, so that's the easy. But the X is a little bit more challenging. What's the X value?
Well, the X is just some distance over to the right of C,
A minus C.
which we can
And,
get.
it's a parallelogram. That's kind of the trick here.
Wait, I see it. I see it.
You might have said, I don't know if Jack said it or not.
I see
What do
it.
you got?
A plus C.
A plus. So A would be the distance from here to here, right? So this
And that's the
distance
amount
right
of
here is A. So
And
that
that's-
distance is A. If you add it to C, then you're right there. We don't want that.
You
we
add
want-
it to C.
We want this part. What do you want?
Add that to C.
Oh, add it to C.
To the variable C.
Because C winds up being right here. So if we add this piece to C, then it would equal that part. You see that?
So it's AC comma B.
A plus C.
A plus C comma B.
Okay, so A plus C comma B, that's kind of messy. Although it won't be messy on the video because they can't see what I marked. So there's your first tricky one, right? Once you see what's going on, it's not that tricky. Now, if this was not a parallelogram, if this was just a quadrilateral, you can't do that trick. So we did this corner, this corner, and then finally that corner.
What if we have to solve for B?
What if we have to solve? We could, right? They're gonna see that they're gonna give you some values starting tomorrow. All right, so we used A, B, and C. That's 3 variables. All right, isosceles trapezoid. Allie, what do you think?
So put A on the origin.
Okay.
So A is 0 0. And then B would just be A comma B.
Okay.
And so then C would
Do
be,
D next.
so D would be C comma 0. And so then C would be C minus A
Why C minus A?
because AD is longer than B.
Could you do this with any trapezoid other than isosceles trapezoid?
No, it would probably just be.
Good. You could do it with a right trapezoid. You could, but this particular one, no. I mean, a regular trapezoid, you can't. So this, what was the final answer?
C minus A.
C
comma
minus
B.
A comma B. There you go. Cool. So parallelogram, you kind of add something. Isosceles trapezoid, you're subtracting something. And there are a couple of those tonight for homework as well too. In fact, the only shape I did not do was the square, which you guys will be fine. We did a rectangle, so.
You didn't. You're not going to do 10 either.
Well, what's the shape on 10?
It's a parallelogram.
We did it.
You don't think 10 is a parallelogram.
No, not a parallelogram. My bad.
It's a
It's
quadrilateral.
a quadrilateral. Why did I say parallelogram? It's a
And
quadrilateral.
so, but they're going to give you some information.
I mean, all you gotta do, and probably just me, an idiot, I forgot.
You're going to have to read through.
All you
all
gotta
of it.
freaking do, no, all you gotta do, and I forgot how to do this, is just
Well, that's a problem.
no, not forgot. I don't understand. No. Figure out. Wait. Yes.
All right, I'll let you chew on number 10. All right.
I figured it out.
That's the revert. Irregular trapezoid, right? We got no choice, right?
Figured it out.
See what you can do. I mean, that's pretty much it. A is at 0, 0. B is at A, B. D is at C, comma 0. And where's C?
Just C, comma, C.
Right, D, comma B. And that's all you can do. So, 4 variables. I don't believe, I gave you a quadrilateral on 10. It's not a trapezoid. That one's even worse. You're going to find out there are lots and lots and lots of variables for that one. Remember why we're doing this is because we're going to do a proof tomorrow. What's homework like? Oh, it's easy, sort of. McKinley, what number are you on?
I'm on number 5.
Well, that's pretty good. Encountering any problems?
Squares tripped me up for a few seconds, but then I figured out.
And remember, we did it just like we did the rectangle. We put its axis of symmetry or its line of reflection right on the y-axis. Now, where they came up with their letters, they're just picking letters at random. And they got G's and H's, N's and O's and T's and U's and Z's. They're going crazy.
Yeah, the book always does. They're always like, hey, do this with an R. Why don't you just say
R.
It's pirate math.
R.
All right. If you run into a problem other than 10, I'm going to let you mess with 10 all by yourself without help.
Aha! I figured it out.
Yeah, because they're all the same.
Good for you, Ben.
Oh, yeah.
I got words. I got woods.
What, sir?
What?
And that'll be it for today's class. Online learner.